Hello, everyone. So, in this podcast, we're going to be getting into some things. And what we're going to be talking about is simply the science of tanker thickness and sanding risk. And some of the things that we see out there is a lot of hype and a lot of things that are put out on social media from influencers who, and also from folks who have gone off of what they've heard or gone off of rumors or what have you about what can and cannot be done or what should or should not be done. And I want to talk to y'all about some facts and backed up with some scientific proof, and also regulations and things like that are set out by the DOT and also by other safety regulators such as OSHA, NIOSH, etc. A lot of folks wonder why we don't sand tankers and why we don't sand tanks. EXQUISITEMAD and EXQUISITEMAD has developed processes, methods using products that are developed in-house with EXQUISITEMAD. We do not use any products that are available on the mass market that is marketing by retail manufacturers, etc. We manufacture our abrasives, micro abrasives, and also our polishes, polishing oils, etc. in-house, even our wax. We actually manufacture and produce in-house, and we use it on site. So workflows, everything that we do is trade secret, and also we are protected by trademark as well. So we are number one in the world for tanker polishing. We're trusted by many different companies, large companies such as Shell Global, Freeport Oil Company, to also handling licensees with Citgo and many others. Internationally, throughout the entire country of the Bahamas and the Middle East, throughout the Caribbean, and also, of course, across the United States of America. So what we're going to be going over here is going to be a scientific article that comes off of EXQUISITEMAD, off of our website. And we have a technical journal that has a lot of scientific articles, such as this one, what we're going to be reviewing here. And it's very helpful to break through the noise and set some realistic expectations. And also, this is informational. So one of the things that we run across with the business is, not all the time, but sometimes, is that folks who have tankers and companies who have tankers, they assume that we do sanding. We do not do any sanding, and we're going to talk about the reason why. There are legal ramifications and also safety ramifications of doing it. And people need to understand that if a piece of equipment is so far gone and so far abused, we are not able to restore that. We don't do restorations. We do not do body work. That is not what we do. We do not advertise it. We never have. We've never marketed it as what we do. We do not do that. We do not do body work. We do not do restoration. We do not make anything like new. What we do accomplish is improving the aesthetic appearance and also improving the optical clarity as much as possible and as much as what the pre-existing surface allows us to. So, and pre-existing surface dictates outcome. So, with that being said, we're going to get very deep into this. So, the science of tanker thickness and sanding risk, 2,800 to 9,000 gallon tankers. And also it goes for smaller tankers too. If you have a 1,500 gallon tanker, it doesn't matter. But these are the most common sizes that we run across worldwide and internationally. So now, a lot of our larger clients and with major corporations and major companies, publicly traded companies, they understand this already. This is informational for smaller businesses that are out there, whether you be a very, very small transport, logistics, transport and delivery company that's delivering chemicals, fuel, gas, that's here in the U.S. So let's get a little bit overview here. EXQUISITEMAD, the science of reflection. All right, abstract. Aluminum petroleum tankers are precision engineered vessels regulated by DOT under 49 CFR parts 178 and 180. Sanding or grinding removes base metal and can push a tank below its design thickness. This paper quantifies removal effects, shows compliance thresholds, and explains EXQUISITEMAD's non-destructive polishing philosophy. With this being said, wall thickness on these aluminum tankers typically range between 4.6 and 5.3 millimeters, depending on size and position. Removing the metal, even in small amounts, can push the tanker below design minimum thickness, which can lead to non-compliance with DOT regulations and increased risk under pressure and impact. For 2,800 gallons, the typical gauge, this is the millimeters here, 4.83 millimeters, okay? This is the typical, okay, representative. 3,300, 4.83, 4,000 gallons, bobtail, 4.83, 4.83 for 4,500 gallon. Then when you get into the 5,000 to 6,000 gallon tankers, they are 4.57 millimeters thick. And then when you come up to 8,000 to 9,000 gallons, these are 4.57 to 5.23. Gauges are representative of Williams specs. Heil, Polar, and Young's design governs per 49 CFR section 178.320A. Okay. There are governing regulations and governing bodies of this. So, as you can see, there are governing regulations which are 49 CFR 178.320, 49 178.345, which dictates the shell head thickness must meet or exceed design minimum. Then it has 49 CFR 178.346-2, DOT 406 construction requirements, 49 CFR 180.407 inspection, testing, UT where corrosion, abrasion exists. Then we get into 49 CFR 180.417 record keeping for tests and inspections. Then 29 CFR 1910.106 OSHA workplace safety for flammable liquids. So these are governing regulations. So polishing versus sanding difference. Okay. This is actual measurements here that have been scientifically taken. So light machine polishing for what we do is it could take off 0.0025 to 0.0075. It's only cosmetic only. Even with our aggressive compounding, which is the most aggressive that we do, is still 0.010 to 0.015. It's non-structural. We're not doing anything to the structure of the aluminum. We're not doing anything to the structure of the metal where there is no structural change. Now, as soon as you get into sanding, like what you see and what you hear about on a lot of social media influencers and what is pushed through hype, through people just repeating things that they don't know. And that is why I'm going to explain this. So fine sanding, even when someone says just sand at 400 to 600, you're light flattening. As soon as you get into medium sanding, which what you see a lot of people doing, to remove, let's say if you have a divot or a gouge in a tank and it is 1.3 millimeters thick. Now if you come back up here, you're looking at one of these brand new, even on a trailer, is 4.57 millimeters. Now if you have something that is 1.3 or 1.5 millimeters deep, which typical pits can run at least a millimeter, and we're talking not so much pitting, but we're talking about gouges from road debris, sanding, from sandblasting, from road debris, from rocks, things like that. It could easily be 1 millimeter. Well, in order to get that smooth and to remove that is exactly that. You're removing material. Now, I'm going to go back to that. So hold on to that. Medium sanding, 220 or 320, you already are a noticeable thinning. Okay, you're already taking off 0.025. As soon as you go to coarse sanding, okay, you're at significant loss. Okay, 1 millimeter sand out. Okay, what people don't understand is if you have even a 1 millimeter gouge, no telling how long it is, how small it is, 1 millimeter gouge deep, means that you have what people are doing in order to get it back out to a mirror. And what you're seeing is aggressive sanding to sand down where that gouge is. Okay, sanding down that aluminum all the way down to at least 1.2 millimeters, because you have to go past that. You have to go past it. You have to go past the depth of that gouge, and you have to take that material down. So now you're actually down to 1.2 millimeters. And this is on a very, very, using a very, very minimal amount of damage here. So that's the reason why this is used, 1 millimeter sand out. Now, once that's done, it has to be done at least 320 to 220 grit, and then stepped off, and then the grits that it's sanded with is higher and higher and higher. Well, each step that you're going, what you're doing is that you're still removing material. You're just removing it at a slower rate as you go up in grits. So at a 320 grit, you remove the material, you now have the surface smooth, but now the person, if they're doing anything, what is being shown out there is they're going from 320, 400, 600, 800, and then getting to polishing, which polishing takes off very minimum. But when you're talking about each step, progressive step of sanding, you're removing this amount of material all the way up. As you're stepping up, when you stop right here, from here to here, you add up all these numbers here, and that's how much material in total that you removed. On top of this is on top of the 1 millimeter that you've already removed, just to get to a part of the surface where it removed that gouge and where you leveled that surface out. So you're looking at about 1.5 millimeters, at least. If you're starting with 1, you could be easily sitting around 1.5 millimeters of material taken off, and that's on a bare minimum. A lot of tankers, if tankers have been used and they're older, they have gouges, they have things that are in them. We don't touch any of that, okay? So when we're coming here, okay, this is, I'm going to open this up here. All right, there we go. So structural impact and compliance. Okay, so this is real numbers here. All right. So structural zones of impact in compliance. Okay, there we go. I'm going to move this over just a smidgen. That way you can see it. Okay, that ought to be good. All right, so when we're looking at this and you're looking at nominal millimeters, nominal means that this is the ideal, okay? If you are, this is actual measurements if you're removing certain material, okay? Nominal thickness is 4.83 on a bobtail, okay? Remaining, just with regular wear and tear, this is regular washing, regular wear and tear, on a bobtail that has been used without any type of work being done to it at all, usually sits with normal degradation and deterioration of the metal, normally sits around 4.33 millimeters. If you remove 1 millimeter, okay, at 1 millimeter, you are left with 3.83 millimeters. If you remove 1.5, there's 3.33 left. If you remember 2, if you remove 2 millimeters, you are left with 2.83 millimeters. At 1 millimeter, you're losing 20.7% of the structural thickness of that tank. If you remove 1.5 millimeters, you're removing 31.0%. 31%. If you remove 2 millimeters, which is 41.4%. Anything, okay, anything that is in compliance, as soon as you get down to 3.9 to 4.3 millimeters thick, it's bad. And what's really wild is that if you're at a loss of 3.9 or less thickness, 3.9 millimeters or less, you're no longer in compliance. So according to the DOT and according to standards, average standards for bobtails. So by taking down 1 millimeter, 1.5, and 2.0, 2 millimeters, you're already under DOT compliance. Trailer, this is trailers for tanker trailers, okay? This is for the top. Same thing goes here. Nominal. Now, it's even less than a bobtail. They start off at a nominal thickness, which means ideal, 4.57. Remaining at 0.5 millimeters, worn off over time, washing, what have you, just normal wear and tear. Average that tanker trailers at the top of them, on the top half of the side, going up, is 4.7 millimeters. 4.07 millimeters. If you remove 1 millimeter, you're left with 3.57. 1.5 millimeter removal, you're left with 3.7. 2 millimeter removal, you're down to 2.57. At 1 millimeter removal on a tanker trailer, you're at 21.9% reduction in tanker thickness, wall thickness. At 1.5 millimeters, you're down to 32.8% and 43.8% with 2 millimeters removed. Anything under right here between 4.1 is ideal as far as your thickness. Anything between 3.7 and 4.0 is reason for concern and inspection. Anything that is less than 3.7 millimeters thick is non-compliant when it comes to these. So when you're looking at any of these numbers here, they cannot be sanded. They really shouldn't. Same thing when it comes to the bottom of the trailer here. So looking at these numbers, starting nominal is 5.23. Anything under 4.2 millimeter thickness is out of compliance, is right here. So when you're looking at this, if you have a remaining, nominal is 5.23. This is the bottom of the tank. you have 4.73, and then if you remove 1 millimeter is 4.23 is what is left with. With that already removes 19.1%. Anything more than that, 1.5 millimeters to 2 millimeters material removal, you're out of compliance. It's out of compliance. Visual design minimum concept, this is DOT regulation, where these numbers come from, is 178.320A, and inspection duty 180.407 below. Design minimum equals non-compliant. Okay. Now, these are fleet age and variable thickness, illustrative age by 5%. These are numbers bold down here, and as you can see, as soon as you look at something, this is the average U.S. tank trailer age 15 to 16 years old. ATR 8 2023. Each tank must be measured UT per DOT and safety regulation 108.407. There is no single national average thickness. Okay, these are averages for 15 to 16 year old tankers according to the ATRI 2023. Okay, so when we're looking at this new bobtails 4.83, aged 4.59 millimeters thick, remaining. If you remove 1 millimeter of material, you're left with 3.59. If you come over here and you look at these numbers between, if you're 4.1 greater than 4.1 millimeters thick, you're in the green. If you are 3.7 to 4.0 millimeters thick, then you have to pay attention to it and it must be inspected thoroughly. Anything under 3.7 millimeters thick, it's out of compliance, and that's it. It's out of compliance. So as soon as you remove 1 millimeter on a average 15 to 16 year old tanker, according to data, you're already underneath the threshold of 3.7 millimeters. You're at 3.59. So there's no reason to even look at even the possibility of even the notion of sanding anything with that. Let's look at trailers, tanker trailers. New ones, new trailers, 5.23 millimeters with age 15 to 16 years old. Average thickness is 4.97 millimeters. Remaining, as soon as, now let's look at these numbers. We're at 4.97. That's the average thickness of a 15 to a 16-year-old tanker. If you come over here, anything less than 4.1 millimeters is out of compliance. So as soon as you anyone suggest removing 3.91 millimeter, that means just, someone that wants to sacrifice and just go gung-ho on sanding and they're adamant on it, it already is out of compliance right there. 3.97 brings you underneath 4.1. If you remove 1.5 millimeters of material, you're down to 3.57, et cetera, et cetera. So it's completely destructive, and it's against regulations and safety. It puts everyone on the road at risk. It puts workers at risk, puts the environment at risk. It's just not good. Sanding sequences and visibility. Coarse is 120 through 180, medium 220 through 400, fine is 400 to 600. Then typically what people are pushing is then polish. Every sanding step removes base metal. Polishing cannot rebuild metal. Factory grain and lines remain visible under LED, golden hour, sunrise and sunset, shade, rain, fog, and cloudy light. So there is no such thing as perfection, and we're going to get into that. There is no such thing as a surface being absolutely perfect. Never. Hidden risk of localized sanding and false testing. Spot sanding creates scattered thin patches. Limited ultrasonic sampling may miss these zones, yielding false passes. Non-uniform thickness becomes stress initiation points under vibration and pressure. Safety requires uniform thickness preservation or full coverage testing. 49 CFR 180407. So let me read that again, and we're going to explain this. So when you see people that are sanding material, and it's not just tanks, but any material, if an area has more damage in one place, of course they're going to be more aggressive with sanding in that area because they're removing more material to smooth that surface out, and then that has to be feathered out. With that, you're going to have low spots all over the place. Okay, so this is where it comes into spot sanding scattered thin patches. So when something is thickness tested, it's thickness tested with the ultrasonic testing machine that everyone is aware of that's in the industry, and it's done in one spot. It may be done in 3 different panels, 4 different panels around the unit, but the unit is not tested over the entire surface. Okay, typically it's not, and we're talking about every square inch of the entire surface of a tank. Typically that's not done. So thickness removal and compliance summary. Okay, so this is removal in millimeters. If you remove half a millimeter, it's 10% loss. Typical condition is cosmetic after and is compliant. Well, as soon as you get into 1 millimeter removal, you're removing 20 to 22%. Structural risk begins. Test and review. 1.5 millimeter removal is 30 to 33% removal and loss of the structure. Severe thinning, borderline fail. Removal at 2.0, average loss is 40 to 45%. That is critical loss. It will fail. It will most definitely always fail inspection. Below design minimum is dictated by Regulation 178.320A. Non-compliant is 178.345-2. Addressed 108.407. These are laws, these are rules, these are regulations that are set by the government, by the federal government. Our policy is no sanding, grinding, welding, repair, or bodywork. We do not polish, no polishing of corroded or structurally compromised metal. Polishing only micron level, non-destructive on safe, intact surfaces. This is aligned with 49 CFR 178.320A, 178.345-2, 178.346-2, and 180.47, 180.417. Okay, so from 2,800 gallon bobtails to 9,000 gallon bobtail shells, or 4.6 to 5.3 millimeters. Removing 1 to 2 millimeters is structural change, not maintenance. Localized sanding can hide thin spots and undermine UT testing integrity. EXQUISITEMAD does not sand and only performs non-destructive polishing to enhance optical clarity while preserving compliance. So, things that we do not do repairs and bodywork. We do not perform bodywork, sanding, grinding, welding, or structural refinishing of any vehicle, tanker, aircraft, marine vessel, or component. No thickness testing or structural responsibility. EXQUISITEMAD does not conduct ultrasonic pressure structural thickness testing and is not responsible for measured thickness or structural integrity of any surface before or after service. All testing certification must be performed by a DOT certified inspectors per 49 CFR 180.407 and manufacturer requirements. There is no correction of physical defects. Polishing does not fix, remove, or repair corrosion, chemical burns, gouges, scrapes, scratches, dents, dings, pitting. These are permanent substrate conditions. There is no like new or flawless guarantee. Polishing does not make any surface new or like new, and flawless finish is impossible on raw material. Appearance will vary by lighting: sunlight, LED, golden hour, twilight, shade, rain, fog, cloudy. Even smooth surfaces will reveal grain and lines as light angles change. Our clients are required to disclose any known defects, repairs, damage, prior paint corrections, and metal refinishing before service. EXQUISITEMAD is not liable for pre-existing defects, structural flaws, chemical stains, or hidden conditions. We have a non-destructive practice. All EXQUISITEMAD polishing is on the micron level and non-destructive. We never alter design thickness or compromise structural integrity. Results are bound by condition. So this is a big thing, because people say, well, final results are dictated entirely by the pre-existing condition of the surface. Polishing is a cosmetic process intended solely to enhance aesthetic and optical luster within the natural limits of the material. Polishing does not remove or fix corrosion, chemical etching, burns, oxidation, or substrate damage, nor can it replicate factory uniformity. Number one, safety first, legal compliance. EXQUISITEMAD performs tanker polishing under safety first mandate, using proprietary workflows, methods, and procedures designed to be non-destructive to comply with all federal, state, and local laws and regulations, including but not limited to 49 CFR Parts 178 and 180 DOT and PHMSA, and relevant OSHA requirements. Services are limited to cosmetic polishing on intact, serviceable equipment. Any structural evaluation, repair, testing, certification, or thickness verification must be performed by a properly qualified and authorized parties. References are here. Everything from ATSM, CS Unitech, ASM, Handbook, ATSM, ASM, ATRI, ATSM, and USDOT, BHMSA. So this is the practical explanations to what we do and what we don't do. The practical takeaways for fleet operators: polishing enhances surface appearance and optical clarity without structural risk. That is the difference in between EXQUISITEMAD and any other company on the planet. And what we do is we enhance the surface appearance and optical clarity without structural risk. We understand that sanding can compromise the tank's legal and safe thickness. And we draw the line and set the boundary that real structural testing and repairs must be done by qualified DOT certified inspectors, not detail companies or detailing businesses. Okay, so microns versus millimeters. Tiny removal from sanding adds up fast compared to gentle polishing. So this is just some of the things that we want to talk about on here. Now, since some of you may be wondering, if you have been watching this much, what do you mean by something not being perfect? Well, we're going to get into that. So we can improve the aesthetic appearance of the surface. The benefits of having tankers polished is not just brand power, but also reduction in the heat absorption. It also makes inspections easier and easier on the eyes to be able to spot defects and problem areas because the surface is clean. It's clean, it's pretty, it's clear as possible, so you can spot things a lot easier than it being not. And the product stability, whatever's being transported, the stability by reducing that heat helps. And also, of course, by the surface being polished and by it being flattened as much as possible and by it being serviced that way, it acts as corrosion control. Because if a surface is super rough, once it reaches a certain point, because some surfaces cannot be polished, If a surface is just so rough, and there's only so many things that you could do. So if a surface is very rough, is polishing going to help it? Sure, it will help it to the extent of what that pre-existing surface and what that surface material allows it to be. So if the surface was already in fairly good condition, then it could only look better from there. If it was in a horrible condition, it could only look a little bit better from there. But it's limited by that pre-existing surface condition. But going back, the benefits of having it sanded is, there are no benefits to having it sanded, but the benefits of having it polished is brand identity, ease of maintenance, easier inspections, reduced heat absorption, and that means the product stability, and it cuts down on thermal expansion. So, and it acts as corrosion control. Same concept as what we use in what is seen in aviation and marine and anything else. Keep the surface clean, keep it polished, even at a bare minimum as much as possible. For what the surface allows, that counts as maintenance, and you're doing something to protect that surface. You're doing as much as you can with what you have to work with. So the science of metal polishing, why a perfect finish is physically impossible. Okay. So our main idea is to achieve the highest optical clarity possible in a natural midday daylight without ever compromising the structural integrity of the metal. Polishing is a refinement process, not a repair procedure. It cannot remove corrosion, fill pitting, or correct dents or deep scratches. EXQUISITEMAD produces beautiful, professional, and scientifically optimized results, but does not guarantee flawless like new factory, new finish. It can only improve pre-existing surface. The results are dictated by that pre-existing surface condition and characteristics. Okay, so physics of reflection. Okay, now even the most highly polished metals contain microscopic peaks and valleys that scatter light. You have specular reflection, which produces the crisp, mirror-like shine seen on smooth surfaces. Diffuse reflection occurs when light scatters from grain, oxidation, or microscratches. As surfaces become smoother, they become more reflective, but also more revealing. The finer the finish, the more visible the material's natural grain, directionality, and optical behavior. These phenomena are governed by physics, not technique. So, if, for instance, if you're looking at Teslas, for instance, Teslas have pre-sanding marks in a horizontal grain. Even when polished with exceptional clarity, these lines remain visible underneath specific angles such as low-angle sunlight or bright LEDs. Similarly, on aluminum used in tankers, aircraft, trailers, etc., often displays factory brushing or machining marks below the surface, pitting or corrosion that cannot be removed safely, scratches, gouges, or dents deeper than the polishable layer, age-related tinting or heat staining that appears bronze or red under certain light. That's seen a lot on airstreams. That's seen a lot on tankers. It's seen a lot on stuff that is used a lot outside. And also it's even seen on aircraft. We see it on aircraft, especially vintage aircraft. Polishing enhances reflectivity and brilliance, but not reconstruct, or erase these permanent characteristics. Okay. So corrosion oxidation, metals naturally oxidize over time. This forms a layer of oxide that changes both color and reflectivity. Polishing can brighten the surface but cannot reverse oxidation or corrosion. So let me say that again. So this is a scientific article. I'm going to leave the notes down at the bottom, have references. This is a straight scientific article. Polishing can brighten the surface but cannot reverse oxidation or corrosion. Scientific facts. Polishing does not stop, prevent, or repair corrosion, including pitting, fill form, or irregular corrosion. It does not rebuild or seal corroded metal. We do not polish corroded, compromised, or repair needed surfaces. That means if there's a crack, we're not messing with it. If it's something that is so thin, we're not going to do it. And if something is so messed up and it has not been maintained, we reserve the right to, terminate service right then, and that's it, because we can't polish something that's too far gone. It can't be done. If it's going to be the risk of compromising something even more, let's say if Airstream, for instance, is completely thinned out from it being sanded by people that were stripping the clear coat 20, 30 years ago, and then the surface is just rough to the touch, at that point, there's nothing that can be done. Nothing. We're not going to sand it because it's just going to thin the metal. So older aluminum, such that is found on Airstreams and pontoon boats, often shows a warm golden tint after decades of oxidation. This is a stable chemical state with the alloy not removable discoloration. Okay. All right. So when you're looking at the mirror finish paradox, and this is an actual term, the mirror finish paradox, the smoother a surface becomes, the more visible microscopic geometry. A perfect mirror finish amplifies every grain, line, or texture variation. The faint holograms or directional patterns seen under certain light are not scratches. They are unavoidable result of how light interacts with metal at a microscopic scale. This is known as the mirror finish paradox. Perfection reveals everything. And here's a bit more on the science. To build on this from a physics standpoint, surface roughness is often measured in terms of RA, average roughness, or RMS, root mean square, where even mirror finishes hover around 0.025 and 0.05 micrometers, far from the atomic flatness. Quantum effects and thermal vibrations at the atomic level mean that no surface is ever truly smooth. Atoms are always jiggling, and defects like dislocations in the crystal lattice persist. Chemically passivation layers, those oxides, form spontaneously via reactions like the 4IA or AI plus 3O2 and 2AI 2O3, which polishing might thin but not eliminate. If you're dealing with the stainless steel truck like the Cybertruck, for example, chromium oxides add even more corrosion resistance than aluminum, but can still show undergrazing incidents light due to diffraction patterns. So when you're looking at that, the role of lighting and environmental conditions profoundly affect how polished metals appear to the human eye. Even a mirror finished surface will look different depending on the source angle. The quality of light, the direct result of how light waves interact with the microscopic geometry of metal. Direct sunlight, high noon, produces even specular reflection that hides most fine grain lines and grain. Sunrise and sunset, which is also known as the golden hour, low-angle light casts long shadows across microscopic grain and factory sanding marks, making them far more visible. At twilight, reduced light intensifies, softens reflection, revealed cloudy areas or uneven polish. Overcast or cloudy days, diffuse light reduces contrast but enhances visibility as subtle directional grain or factory sanding lines from the factory. Rain and moisture, water on the surface refracts light unevenly, amplifying texture and oxidation marks. Remember, not all oxidation can or will be removed. It's impossible. Scientifically, physically, impossible. LED and fluorescent lighting, high intensity narrow beams, light travels, even the finest holograms, swirl marks, or micro patterns. The same polished panel may look good and flawless under direct sunlight, but appear muted under clouds and show grain or linear texture under LEDs. These variations are governed entirely by the physics and optics, not by workmanship or quality. So our process relies on mechanical motion and controlled abrasives. We talked about that, least aggressive methods possible. That's the reason why we are trusted to work on fire trucks, big rig aluminum tankers, aircraft, leading edges, Cybertrucks, etc. Each workflow is engineered to protect the substrate while maximizing the optical clarity. These proprietary compounds also provide a temporary, very temporary, protective film that fills microscopic pores in the metal, creating an enhanced gloss and short-term barrier against oxidation and moisture. This acts like a temporary wax or sealant, offering depth, warmth, and limited protection until naturally removed by cleaning or environmental wear. Okay. When we get into this right here, I'm going to show you here, setting realistic expectations. Okay. We at EXQUISITEMAD produces exceptional high clarity finishes, but scientific reality defines their limits. Polishing does not deliver a flawless like new or factory finish. Polishing does not remove or repair pitting, gouges, scratches, dents, or corrosion. Polishing does not stop oxidation or color change over time. Some directional grain, texture, or tone variation is normal and to be expected. So our work represents the highest standard of surface refinement achievable within the physical laws of light and metallurgy. Enhancement, not replacement. Okay. So our polishing services are meticulously optimized to deliver the best possible aesthetic results when viewed under natural midday daylight conditions, where even lighting minimizes the visibility of inherent structural surface textures and enhances overall reflectivity. So these are the references here. The ATSM B244 surface finish measurement for metal polishing. The ASTM E407 microstructural examination of polished metals. LJ Star specular and diffuse reflection studies on stainless steel. CS Unitech fundamentals of metal surface finishing. U.S. Department of Transportation DOT 406, 407, 412 standards. And Tesla Truck Cybertruck Surface Observations 2025. So I hope that this video helps clarify some things. Probably going to split up the metal polishing, why the perfect finish is physically impossible. Probably going to split that off into a different video. But I hope that this video in this podcast is very informative. I hope you got something out of it. This has been enlightening, hopefully, to some of you out there. This is just a lot of scientific based facts, and all references are available here. If you come to exquisitemad.com, click on technical journal, you can click on the science of tinker thickness, for instance, and sanding risk. Everything is there. All the references are there. Definitely check it out. Also, we have case studies. We also have innovation articles of new innovations that we have accomplished. We're actually going to be adding some things onto that. So be sure to like and subscribe. Remember to hit that bell. Also, before we go, we are going to have a product launch of polishes for metals, some polishes for paints, and also wax. We're going to be announcing that shortly here and releasing that information for y'all. So stay tuned. Hope you enjoyed. See you